So now let's redo example 3, except in the calculator. So we went through example 3. I introduced how to construct a confidence interval to estimate a population mean, and we used the confidence interval formula, which I have stated here. Now the calculator, like I said in the previous lecture, has the same formula for the confidence interval for the mean using the t-distribution built into the calculator. So I'm going to show you how to use that now. So the instructions are right here. They're highlighted. How to use the calculator to calculate a confidence interval to estimate the mean when the population standard deviation sigma is unknown. So we're going to go into stat, and then we have to arrow over to tests, and it's option 8. So we'll do this together, and let's do part A. So we're back to example 3, where we're estimating the mean cost of a wedding. And here's the stats that we're going to need to enter into the calculator. So you'll see. So let me go over to the calculator. So let me just share my screen. So we have to press stat, and then we arrow over twice to tests. And you'll see if you scroll down to option 8, it's called a t-interval, right? Because we're constructing a confidence interval using the t-distribution. So option 8. Now, unless you have the actual data set, we're gonna choose stats. So choose stats and then enter and arrow down. We have to enter the mean X bar, which was 40,000. Enter. Now, S with the little X next to it is just S. It's the sample standard deviation. Remember back in chapter 3, this popped up and I told you that the calculator just uses that little sub X as notation, but this S sub X just stands for the sample standard deviation, which was 12,000. And the sample size was 25, right? We selected 25 weddings at random. And for part A, we were constructing a 95% confidence interval. So we have to put the C level here. So that was 0.95 for part A. And now when we go to calculate, it's going to plug into the formula for us. So the one that we did by hand before, it's going to do for us in 2 seconds. There might just be a little bit of rounding error. So we got $35,047 to $44,953. So let's go back to the one that we did by hand. And in red, let me just circle my confidence interval for part A. So we got $35,046.40 to $44,953.60. So you'll see it's off by a couple of cents. There's just a teeny tiny bit of rounding error, versus the calculator, but much quicker, right? And then let's do part B, also using the calculator. So for part B now, we're just changing this to a 90% confidence interval, but the stats are the same. So let's go back to the calculator. So we press stat, we go over to tests. It's option 8, t-interval. And we already have the stats in there. X bar is the same, standard deviation is the same, N is the same. We just have to change the confidence level to 90% or 0.90. And we could calculate. And it's going to give us our confidence interval. So $35,894 to $44,106. So again, it's off by like 40 cents from when we did it by hand. Little bit of rounding error. Right, so here we got $35,893.60 to $44,106.40. So going forward now, in the next example, I'm just going to use the calculator rather than the formula to get our confidence interval. And I expect you to do the same. Take advantage that we have this function built into the calculator. So before we do the next example, let me talk a little bit more about the margin of error. So I pointed out the margin of error in the last lecture. So I said in this formula, so let me just go back up to your formula for confidence interval, which is right here. So remember I told you guys that the t-value times the standard error is called the margin of error. So the t-value times s over the square root of n, we call that the margin of error, and that's equal to e. So basically what we're doing when we construct a confidence interval is that we're taking X bar, the point estimate, and we're adding and subtracting the margin of error, right? We're taking the t-score multiplied by the standard error, which is just E. So we're taking X bar plus or minus E, the margin of error, right? So we could think of the margin of error denoted by E for the population mean. It's the maximum possible error of estimate for the population mean mu using the sample mean X bar. And really, the margin of error represents 1/2 the width of the confidence interval. So when I say the width of the confidence interval, I mean how wide is it? And right in the middle of the confidence interval is going to be our point estimate, X bar, right? So X bar is right in the middle of the confidence interval. And what we're doing is we're adding the margin of error to X bar, and we're subtracting the margin of error from X bar. So X bar is right in the middle of our confidence interval. So the margin of error is just 1/2 the width of the confidence interval. And we'll address that in example 4. So let's look at example 4. So it says, to help consumers assess the risk they're taking, the Food and Drug Administration, the FDA, publishes the amount of nicotine found in all commercial brands of cigarettes. A new cigarette has recently been marketed. The FDA test on this cigarette yielded mean nicotine content of 28.9 milligrams and a standard deviation of 2.8 milligrams for a sample of 9 cigarettes. So A says construct a 99% confidence interval for the mean nicotine content of this brand of cigarette. So I'm going to use my calculator now. I'm not going to use the formula. Let's save ourselves some time. We'll use the formula built into the calculator. But first we have to extract the important piece of information, right? So we're looking at a particular brand of cigarette, and for a sample of 9 cigarettes, we were told that the mean nicotine content is 28.9 milligrams, and there's a standard deviation of 2.8 milligrams. So what we know is X bar is equal to 28.9 milligrams. The sample standard deviation is equal to 2.8 milligrams, and my sample size N is equal to 9. So what we want to do is we want to construct a 99% confidence interval for the mean nicotine content for this brand of cigarette. So not just for the 9 cigarettes, I already know what the mean is. It's 28.9 milligrams. I want to use this sample information to construct a confidence interval for the mean nicotine content of all the cigarettes that are in this brand. So we're going to estimate mu using a 99% confidence interval. So let's go straight to the calculator, and we're going to enter these stats that we have here. So let me just write this down so I could go to the next screen. So we have 28.9, 2.8, sample size is 9, and we're constructing a 99% confidence interval. So in the calculator, I'm going to press stat. We're going to go over to tests, and remember it's option 8, T interval. Let's enter our stat. So X bar is 28.9. S, the sample standard deviation, is 2.8. and my sample size is 9, and my confidence level is 0.99 since we're creating a 99% confidence interval. And let's round 2 places. So my confidence interval is 25.77 to 32.03. So you see my confidence interval in parentheses right on top. So our confidence interval is, so there's a few different ways you could write a confidence interval. So let's do this here. So we could either write it in words using the word to. So we could say 25.77 milligrams to 32.03 milligrams. Or another way we could see it sometimes is in parentheses, like the way the calculator gives it. So 25.77 with a comma to 32.03 milligrams. Or we could also, I don't really write it this much, but just in case maybe you saw it in the homework or somewhere, we could also write it using an inequality. So we could say that mu, the population mean, is estimated to be between, and then we have 25.77 and 32.03. So those are like the 3 ways that we could write a confidence interval. I typically write it the first way and then sometimes the second way, which is the parentheses, because that's the way the calculator gives it. So now the question is, what is the width of the confidence interval? So in other words, how wide is it? Well, it goes from 25.77 to 32.03. So to get the width, you just take the difference between the higher value minus the lower value. So it's going to be 32.03 minus 25.77. So the width is 6.26. That's how wide it is. And then the margin of error, remember I said it's just 1/2 the width of the confidence interval because we added the margin of error to 28.9. So E equals the width divided by 2. So we're going to take 6.26 and we're going to divide it by 2. We're going to chop it in half. And we get a margin of error of 3.13. So that's the number that was really added and subtracted to X bar, 28.9, to get this confidence interval. So that's our t-value times the standard error, essentially. And then let's write a statement to interpret this confidence interval. So the way we interpret this is we say we are 99% confident that the mean nicotine content in this brand of cigarette is between 25.77 milligrams and 32.03 milligrams. So that's our interpretation. We are 99.7% confident that the mean nicotine content in this brand of cigarette is between 25.77 milligrams and 32.03 milligrams. So this is a nice example because, again, we constructed a confidence interval. This time we used the calculator, and I also covered how to get the width of a confidence interval and then the margin of error, which is just 1/2 the width of the confidence interval. So in the next lecture, I'm going to go over example 5, And then I want to point out what happens as we increase or decrease the width of a confidence interval. Okay, so we'll start the next example in the next lecture.